So for question 19, look at our questions here. Given x equals to 2t minus t and then y. So t is a non-zero parameter. What is mean by non-zero parameter means this t we cannot put 0. It is not 0. They just only can tell you this t is not 0. This t is a number, but we don't want to tell you what is the number. It is a non-zero number. So that's what the sentence here means. T is a non-zero parameter. Means t is something. Okay, t is something here. So first part, we're going to differentiate this. Find the first derivative. So in order to find, you can see x is in terms of t, y is in terms of t. So we're going to use our knowledge on parametric differentiation. So for x equation, first step, we rewrite for rational. For rational 1 over t, we rewrite it to be power negative so that we can differentiate x with respect to t. We can read the power. So differentiate 2t, we get 2. Differentiate this, power move to the front, we become positive. Power minus 1 become negative 2. Okay, so for parametric equation, we need to simplify. So this one, t square, t negative 2 means 1 over t square. Okay, what we need to obtain is obtain until dt dx. We have to inverse it. So before we inverse it, we have to simplify it, get it to the same denominator. So here will be times t square, so 2 will be times t square. So for dx dt, what we need is dt dx. So we inverse it, numerator will go down to denominator, and denominator will come up become numerator. So this is our parametric, the first part. From x, we find dx dt and we inverse to dt dx. So for y part, also same. We rewrite the power first. For rational function, 4 over t, we write it to become 4t power of negative 1. So when we differentiate it, dy dt, we get 1. So this is 1 because this coefficient here is 1. So for here, power move to the front, negative 4, power minus 1 become negative 2. So we simplify. For power negative, we move down, become square. Then we simplify it, get same to the denominator, here will be t squared minus 4. So after we obtain our dy dt and dt dx, first question, we're going to show that. So for part A, we're going to show that what is our dy dx. So you can notice that here is dy dt, differentiate y respect to t. When you want to differentiate y respect to x in parametric differentiation, the formula will be dy dx equals to dy dt times dt dx. So what we obtain here, we're going to plug in what is our dy dt, t squared minus 4 over t squared. And then what is our dt dx? We're going to plug in this one. This is t squared over 2t squared plus 1. And then we can notice here, t squared over t squared can be simplified. So it will give us t squared minus 4 over 2t squared plus 1. So this is our answer. But look at our showing here. Although we already obtained our dy dx answer, we can notice that our answer here and this answer, they are in different form. So their format is different. So what we can see here clearly, actually for this rational, and you can see this rational, this is quadratic over quadratic. So this fraction, so actually rational is our fraction form. So this fraction form actually is our improper fraction because quadratic power of 2 over denominator also quadratic power of 2. For this same power of function, they are improper, means they can undergo long division. So we are going to do the long division to simplify this improper fraction where t squared minus 4 we're going to divide by 2t squared plus 1. So perform our long division. How to get this t squared? So I need something multiply with this 2t squared to get t squared. Okay, so I need something to multiply with 2t squared so that we can get t squared. So that something should be, so when we divide, it will be 1 over 2. So we need 1 over 2 here. Okay, so 1 over 2 times this 2t squared, we can get t squared. For the next term beside it, we just only we're going to expand. So 1 over 2 times 1, we get 1 over 2. So this is how we do our long division. So after we multiply, expand 1 by 1, then we're going to see the balance. We can see the remainder, t squared minus t squared finish. So negative 4 minus 1 over 2, it will give us negative 9 over 2. So finally, we can write our answer here. When t squared minus 4 divided by 2t squared plus 1, it will be equals to quotient 1 over 2. Remainder, so negative 9 over 2. Divisor, so divisor at the denominator here, 2t squared plus 1. So we can have a look here. Is it the things we want to show or cannot yet? We have one more step. So 1 over 2 have to factorize out. So when 1 over 2 factorize out, it will give us 1 minus 9 over 2t squared plus 1 shown. Okay, so this will be our part A. Okay, so we continue for part B. So look at part B here. They say hence. When we have a wording here, when we have a keyword here, hence. So this is very important keywords. This keyword indicate that you have to use the previous result. Our previous result is part A lah. So I have to use this result. This result to deduce means to conclude out, like to give a logic conclusion that this dy dx is less than 1 over 2 for all value of t. So this is like analytical method that we learned in chapter 2, where we learn inequality. So we look at our dy dx, you can see from our dy dx here, it is 1 over 2. So this is question B, 1 minus 9. So from our knowledge of analytical method, what can we see here? We can see something square. When we have something square, it confirm positive for whatever value t we put in. So let's say like our t is negative, our t is 0, our t is positive. But when the t square, we will always get back to the positive result. We always get back to the positive answer. So this answer always positive when it times 2 and plus 1. So definitely the 2t squared, we can say this factor always positive. Okay, so this factor always positive. So when we say a sentence say 2t squared plus 1 always positive, we change to mathematic terms, it will become mathematic writing, it will become greater 0. So greater 0 means always positive. So from here we have to deduce, we have to analyze our dy dx so that we know our dy dx is less than 1 over 2. So how to do it? We'll look at here. So this is our denominator part. So I want to obtain this fraction. So when we times a 9 here, we times a negative 9 inside. Okay, when we inverse it, okay, so we inverse it first. When we inverse it, maximum will become minimum, so less than 0. Okay, when we inverse it, maximum will become minimum less than 0. So when it time with negative 9, when it time with negative 9, so 0 also will be time with negative 9. So your maximum value still is in 0 form. Okay. Then, okay, so we proceed. Then we have a 1 here. So means this fraction will going to add in 1. So this fraction we're going to add in 1, value 1. So your maximum value as maximum that we can get is 1. Because when this left hand side plus 1, so means the right hand side also we're going to plus 1. Then we look at over here. So the whole factor time with 1 over 2. So this factor time with 1 over 2. So means our maximum value original is 1 when we times over 2. So it will become 1 over 2. So what is this? This is represent this is come from our dy dx. So this is how we deduce. So therefore, dy dx always less than 1 over 2 for all the value of t. Okay, look at here. So I will give you a value so that you can see. So like what you can do is 2 less than 5. Okay, so 2 is less than 5, the status, because now we're doing inequalities, right? So we have to know the properties. So when I inverse it, 1 over 2. When I inverse it, 1 over 5. So when I inverse it, original maximum is 5, minimum is 2. So when I inverse it, you can notice that our situation is different already. 1 over 2 it will be greater than 1 over 5. So therefore, just now my minimum value is 0. When I inverse it become fraction, 1 over, when I inverse it, bila kita songsankan, nilai minimum dia sukan jadi nilai maximum. So dia akan less than 0. So maximum value now is 0. Then when we time negative 9, so 0 times anything also 0. So doesn't have any changes in the value here. Masih lagi kosong, because kosong dalam negatif masih lagi kosong. Tetapi bila kita tambah, so contoh this side, bila dia tambah 1, 3, that side tambah 1, also they will get 4. So masing-masing the left hand side tambah 1, right hand side pun akan increase by 1. But the inequality status still same, not going to change. So that will be our properties. So when we multiply also, they will still carry on the same thing. Okay, so I refine here. It should be positive 1 over positive 2 positive. Here, positive 1 over positive 2 positive. So when I time with negative, then only become change, the sign changes here. So I didn't notice the negative here. Yeah, okay. Does it make you confused? Okay, kita boleh sekali lagi. This factor is positive. Then 1 over positive still positive. The thing still positive. But we time negative 9. So we need to change sign. Okay, so if we time negative, kan kita kena tukar change sign. So this side time negative 9. This side also time negative 9, but 0. Still maintain it. Still maintain at value 0. Then continue the following concept is still same. So plus 1 here also plus 1 times 1 over 2 here also times 1 over 2. Boleh? Continue to our question C. Find second derivative when t is equal to 1. So this one, we will going to find our second derivative. So our formula, okay, we revise our formula to find second derivative. It will be going to differentiate respect to t for dy dx. Because our dy dx here is in terms of t, we're going to differentiate respect to t, then we need to time with dt dx. So always use chain rule in parametric differentiation. So we're going to differentiate this. So before we going to differentiate this, I will going to refer to dy dx to the easier form. So I will refer this form. If I refer this form, you're going to product times. So simplify it. Time is 1 by 1. We're going to differentiate. We're going to differentiate for 1 over 2, then minus 9 over 2 2t squared plus 1, and then time dt dx. So I haven't start any differentiation yet. I just write the formula only. Okay, so I have to rewrite the form that I want to differentiate here. I can put this 1 over 9 over 2. Here will be 2t squared plus 1 power of negative 1. So I want to differentiate this. So this is the form which are ready for differentiation. So differentiate constant, we get 0. So differentiate this bracket, we use power rule. So power rule say this one, power move to the front. I get 9 over 2, power minus 1. We get negative 2. Then differentiate inside the bracket. Inside the bracket here got 2t squared. So power move to the front, power minus 1. Then differentiate 1, we get 0. So this is our dy dx differentiation. Multiply with dt dx. So look at our dt dx that we get just now. dt dx is t squared over 2t squared plus 1. So we can directly substitute our t equals to 1 because our question is asked for d2y dx squared when t equals to 1. So when t equals to 1, we evaluate out our d2y dx squared, so no need to simplify here. What we want is our value. So substitute t squared, 1 squared, this is 3. So substitute 1 here, it will be 4. Then times 1 squared is 1, 2, 1 squared, here is 2, 3. So press your calculator. We will get 2 over 3.